Hello viewers, today we are diving into a facing world of Radix sort and it increases. First up, we are going hands-on with the implementation of Radix sort using base R in our chosen programming language. Buckle up as we walk through the code, breaking down each step to give you a solid understanding how this sorting algorithm works. Action. We will even throw in particle example to see the message unfold. But wait, there is more. We are not stopping there. We have delving into the theoretical realm with a deep dive into the running time analysis of Radix sort. Picture this, sorting n integers, not just n integers, but does into the range from 1 to n square. I will guide you through the algorithm's main steps. Underlining the complexity of the process. Then brace yourself for some mathematical expression as we delve into the hard big annotation, breaking down the time complexity like never before. So, grab your favorite beverage, sit back, and let's embark on this educational journey together. By the end of this video, you will have solved Grab's Radix sort, but code and in its theoretical runtime increases. Let's get started. This one, Başkent University, PDF, the exception, the Radix sort algorithm, and for page. And I explain the for page. Yes. I will be introducing you to Radix sort algorithm and its history. Radix sort is generally known for its efficiency, often measured as ON, making it faster compared to other sorting algorithms, especially those falling under the ON square category. The origin of this algorithm dates back to 1890 when Herman Aldrich, working at the USA, Kansas Bureau, developed a method for his tableting machine. These machines use punch cards at that era to sort numbers and process data. Now, let's delve into how Radix sort works. This algorithm sorts numbers by grouping them according to their place values. This approach sets the apart from other sorting algorithms. For example, using base 10 system, the algorithm iterates through to each place value. I would also like to share with you a Java program. This program sorts randomly generated numbers using the Radix sort algorithm, but I can generally Python program. It's seeing. The program conducts sorting by grouping numbers based on their place values in each pass. The program generates an underrated array, prints it to screen, then uses the Radix sort algorithm sort it, finally printing the sorted array. This is Java. Yes, you see import to Java line, import to Java IO, public Radix sort. You writing the algorithm and I think the homework 5 and I asked me to ChatGPT. Let's think. Yes, I asked ChatGPT. Give me a basic practice question on Radix sort with base R. Yes, I'm asking. Thank you, ChatGPT. And I solved this problem. Consider the following list positive integers. Yes, numbers are is n. Show the intermediate steps of algorithm, including the distribution of elements into the buckets at each pass. Yes, buckets. Okay, thank you. Yes, we have got these list positive integers and we are dividing into a magical word Radix sort with base of 10. Imagine we are sorting these numbers by their digits, starting from the last signification digit and working our way up. Pass 1, we create buckets for each digit from 0 to 9. We start starting the numbers based on their last digit. So 700. Yes, I wait. Yes, yes, you see. And it goes buckets. This bucket 2. And so on. After this pass, our list looks a bit shuffled, but we have started the sorting process. This time the pass 3 is 2. Yes. Bucket 0 is null. We rearrange our numbers based on these digits, referring our order as bucket 1. Jump to bucket 1. And bucket 5 is starting the tag shape and pass 3. Using the pass 3 and the numbers in the final stage. We focus the most significant digit. The number gets sorted within their buckets, and we are almost there. And bucket 1 using this, and bucket 3 jump, and bucket 4 jumping again, bucket 5. Now we just concatenate the elements from buckets in order, and voila, we have our sorted list. We have the sorted list. And there you have the beauty Radix sort. And I installed the Python code using I experiment the Radix sort. This Radix sort function finds the maximum number in the array to determine the number of digits in it, and then performs contained sorts to each digit, starting from the last signification digit and moving towards the most significant. And you think the counting sort. This is a modified version of the counting sort algorithm. It counts the occurrence of each digit at the current place value, adjusts the count array, and then builds the output array accordingly. This is the and you build the ChatGPT example. This is the numbers. This function takes an array R as input and stores it using the Radix sort algorithm. It first calculates the maximum number in the array maxnum. to determine the number digits and maximum number. Then it iterates through each digit's place from less significant to most significant using the variable exp the short case. In each iteration, it calls the counting sort function. Yes, this function modified the version the counting sort algorithm tolerate for the Radix sort. It takes an array R and exponent the exp is input. The third loop builds the output array based on the digits position calculated in the previous steps. Finally, it copies the sorted output array back to the original array R. And this is the example. This part demonstrates how to use the Radix sort function as sample array that prints the original sorted array. Yes, I played the algorithm. Yes, this started. Okay, original array and the Radix array. See the small one and the big one. Thank you. And we will use example. Is that true? Thank you. Okay. Abuse systems errors for steps of let me calculate correct mistakes. Okay. Escalate accomplish. There you go. Yes, and I skipped the second question using. Yes, I asked the ChatGPT. Give me a basic practice question on analyzing running time Radix algorithm to store the n integers in the range 1 to n square. Oh, but solution. Okay. This is the sample question, but I solve it. Yes. Radix sort is a non-comparative sorting algorithm that works by distributing elements into the bucket according to their digits and collecting them in order. Time complexity of each pass. Each pass involves distributing the numbers into bucket space on a specific digit and then collecting them. For each integer, we perform constant time operations for each digit. I ask complexity of each pass. Yes. Go again.
Suppose there are all log n passes over time, the maximum radix for the n log n. Okay. The maximum number of digits range of 1 to 2 n square. Yes, that's it. True. Does the time complexity each pass all log 2 n square? May I log speak log 2 n square? Yes, you can express. Yes, this is true. And number of passes. Number of passes. Number of passes in Radix sort is determined by the number of digits in the maximum number. As established earlier, this log 2 and 2 n square n square and okay. Yes, you give me overall time complexity, overall time complexity. And log n. That's true. And last one. Simplifying expression. Simplifying expression. All again. But that is false. But I think that's false. That is false. Because log multiplication log n. Scenarios. Okay, I understand it. This my scenario. This scenario is not true. Okay. And final. You give final time comes like final time complexity. Yes, that is true. And by writing the Python code, that is the algorithm I explained for while for and finds the maximum. This Radix function finds the maximum number in the array to
determine the number of digits, performs counting sort for each digit, starting from the less significant and moving towards the most significant. And the counting sort counts occurrence of each digit at the current place value. Using counting sort modifies the count array store the actual position of each digit in output array, builds the output array based on the digit position, copies the output array back to the original array to complete the sorting. Yes. And I played this function. Yes. This is the finish. Yes. You give the small one and the big one. Thank you. This is my homework 5, and you see it. Thank you. You see it and listening. Bye bye. Next homework 6. Bye bye.